Welcome everyone. Let's learn how to evaluate the limit of an absolute value function. Our strategy will be really simple. If the value we are approaching, when we plug it in, makes inside of the absolute value 0, we will check the limit from left and the right. If when we plug in the value, it doesn't make inside of the absolute value 0, we will just plug it in and we will have our answer. For example, limit of absolute value x plus 4 as x approaches to 2 from the left side. Plug it in, 2 plus 4, 6. It's not 0. I will have my answer as 6. Let's use a different color though. My answer is 6. Limit of absolute value x squared minus 5 as x approaches to 3. Plug it in. 9 minus 5, 4. Limit of absolute value x over x. Plug it in, 0. Inside of the absolute value is 0. We have to check the limit from the left and the right side. Let's check it from the left first. Since I'm approaching 0 from the left side, I am lesser than 0, which is a negative value. So this limit will be negative x over x as x approaches 0 from the left side. Cancel the terms, negative 1. Limit from the right side. This time, absolute value of x over x. I am greater than 0, so this is a positive integer. X approaches 0 from the right, x over x. This limit is 1. Since these are not equal, we will say this limit does not exist. Limit of x approaches to 1, probably. Limit of x multiplied with absolute value of x minus 1 as over x minus 1 as x approaches to 1. Try to plug it in. 1 minus 1 is 0. Inside of the absolute value is 0. We have to check it from the left and right immediately. Limit of x multiplied with the absolute value of x minus 1 over x minus 1 as x approaches to 1 from the right side. When I approach it from the right side of 1, inside of the absolute value is positive because I'm greater than 1. Therefore, we can write this as limit x approaches to 1 from the right side, x multiplied with x minus 1 over x minus 1. Cancel these terms, plug it in, 1. From the left side, limit of x multiplied with absolute value of x minus 1 over x minus 1 as x approaches to 1 from the left side. I am lesser than 1, therefore inside of my absolute value is negative. It will come out as negative x multiplied with x minus 1. I just wrote the negative first. That comes from the absolute value over x minus 1. Cancel these out, plug it in, negative 1, not equal. This limit does not exist. Limit of x squared minus an absolute value x squared minus 1 over absolute value x minus 3. Clearly, when I plug it in inside the absolute value, inside of it is 0. We need to check the limit from the right and left. But first, I want to remind something. Absolute value a multiplied with b can be written as absolute value a multiplied with absolute value b, because we will write x squared minus 9 as x minus 3 multiplied with x plus 3, and we will take these two terms out of the absolute value. We will write these as separate absolute values. Let's check it from the right side first. Absolute value of x minus 3 multiplied with absolute value of x plus 3 over absolute value of x minus 3. From the right side, I am greater than 3. Everything will come out as positive, so this limit is 6. From the left side of the 3, absolute value of x minus 3 multiplied with x plus 3, absolute value of course, over x minus 3. Now these come out as negative, but they also reverse the signs because they will cancel each out. So the answer is again 6. Therefore, this limit is 6. Limit of absolute value of sine x over x. First, we need to check if inside of the absolute value is 0. What is sine 0 is equal to? It is 0. Therefore, absolute inside of the absolute value is 0. We need to check the limit from the left and the right side. limit of absolute value sine x over x as x approaches to 0 from the right side. In this example, when I approach sine x from the right side of 0, try to plug in a value, we will see sine x is positive. So this will come out as limit of sine x over x as x approaches 0 from the right side. To evaluate this limit, can we use squeeze theorem? The first thing that comes to mind is squeeze theorem, or we can just remember our special limit. This limit is special for us. It's equal to 1. Let's not prove this in this video. When I approach it from the right side, it came as positive from the absolute value, which is 1. Limit of absolute value sine x over x as x approaches to 0 from the left side. This comes out as side of sine. Does it comes out as negative sine x? Let's think from the left side of 0. Sine x, yep, it comes out as negative sine x over x, which is equal to negative 1. Again, this limit does not exist. Limit of absolute value of x over x as x approaches to a really small looking value, but when you think of it, there are a lot of numbers between this value and 0 still. And this is not approaching the 0, so this does not make inside of the absolute value 0. Therefore, you will just cancel these two terms, or you can just plug it in. 0, 0, 0, 1 for x, which will make this limit 1. We do not need to check it from the left and the right.